So let's graph each line, and I have several examples. Our first example says graph y equals negative 2/3 x plus 2. Y equals negative 2/3 x plus 2. To graph this, I must choose x values to fill in place of the letter x. Notice that I have a fraction as a coefficient of x. Now I could use, for instance, 1 in place of x. If I do, I will have negative 2/3 times 1, which is negative 2/3, which I must then add to this integer 2. That will give me a fractional expression for y. And that's okay, but it's not as easy as integers. Can I choose an x value that will give me an integer for y? Of course I can, as long as the x value I choose will reduce this 3 denominator away. That means that if I use a number like 3 for x, I can cancel the x number and the 3 denominator and end up without fractions. Besides 3, I can use 6, 9, 12. What about my all-time favorite number, 0? What is a fraction times 0? Well, you know that any number times 0 is 0, and so if I use 0 for x, that will be an outstanding choice, and the fraction part of this will disappear. I could also use negative values. I could use negative 3 for x, negative 6, negative 9, and so on. Any number that is a multiple of 3 will cancel the 3 denominator and would be a wise choice for x. I'm going to use negative 3, 0, and positive 3. Negative 3, 0, and positive 3. 2 points to determine the line, a third point to check. I like using negative and positive numbers because that means that the graph has some values to the left of the y-axis as well as to the right of the y-axis. That gives me a nice feeling of symmetry about the graph. I always like using 0. Remember that 0 is our all-time favorite for a choice of x, because 0 times anything is 0, and that term will disappear from the equation. So let's go through the solution. Filling in negative 3, I have y equals negative 2/3 times negative 3 plus 2. Negative 2/3 times negative 3, the 3's will cancel. 3 goes into 3 once, 3 goes into negative 3 negative 1 time. Negative 2 times negative 1 is positive 2, and 2 plus 2 gives me 4. And so we have negative 3, 4 for the solution. Now I'll fill in 0. Y equals negative 2/3 times 0 plus 2. Negative 2/3 times 0 is 0. 0 plus 2 is 2. And so I have the point 0, 2. Now I'll fill in 3. Y equals negative 2/3 times 3 plus 2. 3 goes into 3 once, 3 goes into 3 once, and so I have negative 2 plus 2, which is 0, and I get 3, 0 as my ordered pair. So my 3 ordered pairs are negative 3, 4, 0, 2, and 3, 0. Let me slide this page over and we'll put the graph to work for us. On my graph, I indicate the x-axis and the y-axis. First point is negative 3, 4. For negative 3, 4, I begin at the origin, count 3 to the left, and then up 4. So there's the point, negative 3, 4. Next I have 0, 2. That means I start at the origin and count 0 horizontally and positive 2 vertically. Start at the origin, 0 horizontally, and then positive 2 vertically, meaning up 2. So there's the point 0, 2. 3, 0. I begin with 3 to the right and 0 vertically. 3 to the right and 0 up or down. That means I stay on the x-axis. Do the 3 points line up? Well, my ruler will tell the tale. Yes, they do. And so I can draw the line all the way across the picture, arrow points on each end to indicate that the line does not stop when the picture stops. The line goes on forever. And so here's the graph of y equals negative 2/3 x plus 2. So here's my graph, y equals negative 2/3 x plus 2.